Hi everybody, it's Larry Koch here from Flybox, and today I'm going to be doing a deep dive with you on the sustainability of insect farming. So if you're new to insect farming, or perhaps you've just entered the space or looking to enter the space, and you want to get a high-level view of some of the sustainability factors that go into the sector, then hopefully this video is going to help you understand exactly how insect farming benefits the wider environment, but also how it stacks up financially and where the market is currently with that. So let's dive in, and hopefully by the end, if you have any questions, you can always reach out to me. I'll provide some contact details in the description box below as well. So first of all, we need to just kind of cover off that obviously sustainability has multiple elements. In fact, there's often we talk about environmental as well as social as well as economic or financial, but there are also multiple factors outside of that depending on who you are. Today I'm just going to focus on environmental and financial because really those are the two drivers of the culture, or drivers of people to look at the space. They either want to become better environmental stewards, and insect farming really fits into that narrative and helps them achieve that. But at the same time, other people are looking at it as an economic arbitrage where they can lower their costs of feeds and foods, and basically lower their costs of producing high quality protein. So that's why I'm going to focus on those two. Someone else can watch this and drop some really interesting social aspects. I may do that in another video. So let's start with the environmental. Now, what's going on here is that global meat consumption is going through the roof. Whatever we might think in the, let's call it in the West or in the global North about meat production, people swapping to vegetarian kind of options for meat, trying to cut down their meat consumption. This represents an absolute minority of the effect on meat consumption. So as the population rises, more people enter the middle class, more people desire to eat meat, and of course, this means we need more meat. Now, people actually think that livestock meat is the principal, in terms of biomass, the amount of protein that we produce as a species, that the most of it would be in the form of the animals that we're actually eating. But that's not actually the case. Most of the protein that we produce as a planet comes in the form of soybean, or a large amount does. And so as the kind of single biggest protein source. And this actually goes to feeding our animals. So you and I prefer to eat, or let's say the world at large prefers to eat, animal products and byproducts or livestock products when they're going to consume meat. There's many reasons for that. The nutritional profile, the mineral profile, the amino acid profile of animal proteins is very important, and animals are a very good source of those, basically. Soybean is a close alternative, probably one of the better plant proteins, and so we've been using it as a very low-cost way of feeding our chickens that then end up on the shelves that we then eat around the world. So it's no surprise that the amount of soybean has actually gone up in line with the amount of meat produced, as we need the soy to feed the meat to then feed us. So I'm not here going into entomophagy. From an energy flow perspective, of course, if we could all eat insects, well, for the reasons I'm going to get to in this presentation, it would be a lot more efficient in terms of energy conversion and land use and all these things. That's all very well, but consider that chickens are a lot more efficient as a protein source environmentally and all the rest of it, and yet we're still unable to really stop eating as much red meat as we have. So even people are not prepared to switch from red meat to chicken, let alone chicken and red meat to insects, which has a whole other cultural gap to bridge. So I think it's unrealistic in the short term to start talking or evaluating the environmental impacts of insects by comparing it to the effects of if large numbers of people would just be eating insects. Although those would be tremendous and much higher than the ones I'm going to go through now, most of what I discuss is insects for feed, because that's already going. It's already an industry that's clipping along, and doesn't have those cultural yuck factors that are stopping entomophagy. But entomophagy is a growth area there's also not knocking that whole space. I'm just saying when we talk about the volumes and where a lot of people see this place going as a huge, taking a dent out of that $1 trillion animal feed industry, the most of the protein that we're going to need to look at is replacing things like soy. So you might ask, what is the problem with soy? Why can't we just keep growing more soy? Well, the planet, we come to ecological limits or biological limits. And so we just run out of space to grow enough soy, and we run out of space to farm our animals, depending on how intensively you decide to farm livestock, which is another story. But either way, if we kind of continue more or less along the ways that we're doing things now, we just simply don't have enough space to grow the amount of soy that we need for our animals. And so that puts pressure on natural ecosystems. So people think, well, I'm getting paid a lot more for soy. Why don't I cut down some rainforest? Then I can make soy and make some income from that. You can't blame people for wanting to do that, but it is just not something that will work long term. And so really, when people talk about the problems with traditional proteins and they want to move to alternative proteins, the reason is they want to stop deforestation and they want to stop soy, or they want to stop as much use of soy. Now, I should say that the runner-up to the amount of to the kind of volume of protein that we use is fish meal compared to soy meal. So fish meal used to be quite an intensive process to get fish meal, but these days, I'd say the industry has cleaned up a lot of their act to the extent that fish meal, in some cases, is seen as quite an economical and environmentally sustainable way of getting animal proteins. Fish meal is an animal protein. Certain animals require animal proteins. For instance, carnivorous fish need to eat other fish in order to grow. And so if you want to farm carnivorous fish, well, you need to feed them an animal protein. Whereas obviously soy is a plant protein and lacking in some of those things. So not always possible to use soy to feed most animals. And so that's where that 10% comes from. But hopefully it makes sense to you now that soy is this big, huge monolith of protein that is powering our society and our food system, or certainly our protein system. And that is causing huge challenges for finding enough land. So really that's the core, and all the benefits that I'm going to go through now come from that. The other one is, our wastefulness in general as a society. So people talk about circular agriculture or circular food systems a lot, and it makes sense because a third, some people count even more, a third of our organic waste as a society ends up in landfill, and that again is super unsustainable for the reasons I'm going to go through now. So really, insects being that part of the ecosystem that deals with decomposing matter, this is where they step in again. So they're able to chew through all of the waste that we're throwing away, which is about a third of the food on our plates, a third of the waste from food processing. That then gets upcycled back into nutrients, that could then go into feeding the system again. So theoretically, because landfill is already discarded product, insects kind of close the gap between a discarded product, and they're sort of like nature's recycler, if you like. They're protein recycling stations or nutrient recycling stations, very much like you would do plastic, and then you don't need as much virgin plastic. So the idea here is that if you could theoretically get rid of all the landfill and do some sort of waste to value with it, insects could be one of those things. And so that's where you're getting the other benefits. So all those things, if we look at deforestation, that's the main thing people first hone in on when they're looking at the alternative protein space, the insect protein space. But as you then rear the insects on landfill organic matter, it means that you then have a lot less water, less CO2, less land, and improved soil. Now, I'm going to quantify these facts for you now, but I must say just at the outset that these facts are hard to come at this. There's many journals that have been trying to look at life cycle analyses of different insect farming products and operations. This is by no means a settled science. So any numbers I'm going to give here, I'm not dying on the hill with any of these numbers. It's for you to do your own research. We ourselves as a company have done research on this, but it's very much advisable to be prudent when I tell you some of these numbers. So some researchers, and again, I will leave everything in the description box below with all of the citations, so you can go and check out those papers and see what you think. Also, anyone who's clued up on this topic, I would love you to drop some of your wisdom down below. Other people watching this might find it useful. So I've actually picked them out here so you can see that it's not me coming up with this. So essentially 1,000 times less water would be needed to produce each kilogram of protein if it was insect protein. And so, a lot of people, that's basically compared to soybean. So amount of water you need for a kilo of soybean, you need 1,000 times less for insects. Now, this whole water usage thing, up to you how you want to take it. But for me, something being less water is neither a good nor a bad thing, in my opinion. All that really matters is responsible water system usage. So how are you tapping the water system, and how is the water replenishing the kind of aquifers? So just because something takes 1 billion liters of water, if that water immediately falls as rain the next week, then the system is in a net balance. The problem is when you start drawing water out of areas and it can't be replenished, and then you start changing the ecosystem. So it's not necessarily that one is better than the other, or that one is a disaster compared to the other, but it's worth bearing in mind that if you're having people try build soy based on increased demand in loads of different places, they might be under pressure to push natural water systems, more than they can go. And with insects, you just don't need to do that. Lower CO2. So it's estimated that you could use about 10 times less CO2, so greenhouse gases, compared to soybean farming. So that again comes from you're just displacing all of this stuff with deforestation, because you need to actually displace land to grow soy. And also all of the emissions associated with landfill that you're diverting by processing it in insect farming. Improving soil comes down to the organic fertilizer. So one of the byproducts of insect farming is insect fertilizer, which is essentially the manure of the insect after it's eaten and upcycled all of the nutrients inside food. And so you're left with this very dry, powdery, almost soil coffee smelling powder, which is a very potent fertilizer rich in NPK. Depending on the waste source that you fed the insects, it'll have different levels of NPK, and makes a very good fertilizer, and also has some let's say some pesticide qualities to it, because of the presence of the insect skins. It actually triggers autoimmune responses in plants that actually make them more resistant to real pests. So it's very interesting that a lot of people are actually doing a lot of research right now that indicates that if you were able to totally use all of the landfilled organics and convert them in this way, you might be able to get off quite a lot of chemical fertilizer and pesticides. And then the last one is less land. And here, less land just refers to how much biomass can grow. I mean, with plants, they're growing in the soil. Insects can grow, vertically as well. They basically live inside their feed and their waste, and they can be packed very, very densely. And they eat extremely fast, so they can really cycle through one unit of land very, very quickly. So in 8 days, they can be done with their food. So every month or every period that you're growing soy, you can be just running generations and generations of flies and larvae in the same space. So they've quantified that as well. I will link the description underneath, and that's also quite an interesting one. So next, we're going to go into the financial side of it. So now we've looked at the environmental side and tried to quantify some of those. Let's go into how does the industry stack up financially? Because if you need subsidies to survive, if you can't survive as a actual business, are you sustainable if you can't sustain yourself? And so that is exactly this other element that I think is important to draw people's attention to. Before I do that, just make sure if you are interested in insect farming, you head over to www.flybox.bio. There you can find out about my company and all of our tech products. We help you if you want to set up an insect farm at a kind of semi-industrial scale, whether you're a company or an individual entrepreneur. Don't hesitate to get in contact. Our guys are really friendly. We're happy to also just chat through how you're looking at the industry and go from there. So let's get on to the financial. So the main difference that's going to affect the bottom line, the P&L of a insect farming company is where they're located. And so typically what we've seen is in the global north, the approach where a lot of insect farming sort of developed in earnest, with the exception of South Africa, had a lot of focus on engineering, and some would argue over engineering, but certainly a lot of automation, a lot of process engineering, fully mechanized solutions. Some of the factories pursued by some of the bigger vertically integrated players in Europe costing north of $50 million to build. So we're talking about serious technological factory settings. And then in the global south, you've gone right to the other end where people are doing it literally outdoors, with makeshift environments, with polytunnels, and actually just building it like that. So the cost in building your insect farm, the efficiency, the predictability of the business model, and also the price that people are prepared to pay will depend very, very much on where you are in the world. So that's the summary, if you like. The things that really affect the financial viability of an insect farm are things like the energy costs. So again, if you're in the global south, very little energy cost because you're relying on the local climate to power your temperature. And if you're by the tropical areas or subtropics, you also have naturally high humidity for a lot of the year. So the problem with this approach of relying on the climate is then you are beholden to what the climate does. So I've never seen any place on Earth that has the perfect temperature and humidity constantly. There's always fluctuations up and down, and that fluctuation can create instability and unpredictability in your output. And sometimes unpredictability is worse than a lower output. Like you'd actually prefer to have 20% lower output or even 50% lower output, but to know it's predictable, because then you can create standard procedures, you can hire people, you can train people, you can have a scalable business model, and you know where you stand. Relying on temperature and humidity going up and down does really start affecting how you can run a viable company. So it's not that just because you have a favorable climate, you automatically have a better business, but definitely helps. And if you can intelligently arbitrage the climate that you have, but also make sure that the key areas that are holding up or bottlenecking the process can be climate controlled, that's really the sort of the holy grail. And that's certainly the approach that we champion when we do our work in the global south. We don't want to provide over-engineered solutions, but we also recognize the return on capital for climate controlling specific, highly sensitive parts of the insect's life cycle. The second is the product price. So in the global south, you're going to get maybe anything from $1,000 to $1,500 a ton for dried insect meal, and you're going to get, depending on the place, $200 to $500 for the frass, for the fertilizer. If you start looking in Asia, you get a similar kind of pricing in the global south. It's inching up. It depends on the deals specific companies have, their product spec sheet, how much protein there is. A lot of companies defat their protein, so there's a higher protein component that fetches a higher price, and then they're basically selling oil as well as defatted meal. And then you've got places like Europe, the US, where you're getting some companies selling at $4,000 a ton for insect meal. And in those cases, that's great for those companies, and they have very high standards, but it's generally not seen as something that's super viable pricing at the moment. But again, they have much higher input costs and much higher return on capital hill to climb, let's say. So that's going to dictate what you can sell at. A lot of that is also consumer acceptance. Some of the frass that I've seen sold in the global south actually has better qualities than a lot of the compost that is being sold, yet it's only selling at half the price. You would expect that to change with marketing, education, and the maturation of the industry and people recognizing the value of the products. The third is the regulation and legislative environment. So a country like Kenya, for instance, in East Africa, has adopted the most far-reaching legislation to specifically make it clear that insect farming is to be promoted and to be pushed around the country. Thousands of farmers are being trained. Lots of smallholder farmers are up to it. lots of SMEs are now doing it, and including some big companies. So as an example of there, where we have an office there as well. So it's for that reason that they've just taken it so seriously. And so that then gives you a lot of confidence to build a company there. And you kind of know you have people on your side, and it signals all sorts of important things to potential customers. Whereas if we take the example of the UK right now, it's probably the worst place to do insect farming for now, although that's shortly about to change. Just in terms of the regulations, there's too much red tape. The rest of the world, it's more that they haven't really thought about it, so they've neither put red tape in the way nor explicitly accepted it. So you're sort of in a gray zone where you don't actually know where you stand. And one could argue that's worse in the same way as predictability in energy is worse, in that you'd ideally like to know the limited scope in which you are 100% allowed to do something than not know at all. And so it can be seen as quite risque to just set up a company in a place that hasn't explicitly said they are for or against something. How do we know how the powers that be, the industrial food system that exists, might not align to go counter your interest down the line? So it's very important to take a look at the legislative and regulatory environments. Europe is in a good middle ground where they've been very clear about what they accept, so you know where you stand with them. The UK is shortly to take on the same legislation. So again, everything I'm saying is generalizations. I hope that's understood and that's clear. I'm talking in the round. I'll be doing more videos in the future, maybe one on each of these topics. So just make sure you subscribe to the channel, and you'll get my updates every time I put a video up, and hopefully it's useful to at least jog your thinking, and maybe challenge some assumptions you have about the industry too. But definitely not pretending that I can just sit here and give you a blow by blow, country by country specifics. But these are things all worth bearing in mind. So if we look at the future, then, so we've talked about some of the things that will affect the viability of your business model, right? You've got all those operating costs, the energy, the labor, all these things that change based on your location. But then again, the price changes too. So typically, as labor goes down and energy goes down, still, the price goes down as well. So there's a balancing act. You have to do your business model before you ever invest in an insect farm at all, or start getting into the space. So then basically you've got what's coming down the track, if you like. So the way I see the industry evolving is that the economic systems that look viable to me on the top end will be the large scale factories that get some serious economies of scale. They put in their IP, they make everything more efficient, and they co-locate with existing companies. So co-location is a hot topic right now, but there's examples of partnerships between InnovaFeed and ADM, for instance, where they will be partnering, where the heat and waste from one of ADM's factories will literally get piped in to heat the climate control of the insect factory, and also the waste gets piped in directly to you. So they're really cutting out the logistics. So I think, from what we've seen from profit and loss statements, is like waste transport and waste acquisition can be as much as 30% of the COGS of insect products. What you can do to eliminate that, to bring down your operational costs, massively helps with return on capital and the viability of the enterprise. And so it's the same with, but logistics doesn't have to be at that scale. So when I say logistics, I also mean, can you arbitrage something in an existing supply chain? So are you an existing food company that already has your own waste sources? Or are you a smaller community that has a way to aggregate waste in an interesting way? Do you already sell fertilizer products, or do you already sell composting products? Can you mix in the frass directly in your site and cut out the logistics? There's also other business models that are just working with smallholder farmers so that they can do the farming on their site, and you just supply them with the inputs like the eggs. And so a couple companies are just selling eggs to people and let them do it low cost on their site and feed the insects directly to their animals. That cuts out loads of processing costs, processing overheads, energy costs. So there's multiple different business models where if you really play on the logistics, how can you decrease the amount of stuff going either way, to you in terms of waste, or out to your buyers, and really work from an existing business and existing supply chain. You can do a lot, And where that's not possible, or where you want to scale, you need to really partner on big factories. And then there's just the fact that we are still at the infancy of the productization of insect products. So as time goes on, we're going to see massive changes in all of that. So what I mean by productization is not just, can we make defatted insect meal? Can we extract chitin and sell chitin to the cosmetics industry? Can the BSF oil be used in tractors? There's lots of different ingenious things people are looking at for the insect products themselves. But what I also want to encourage people to look at is, can we develop a new category of responsibly fed livestock products? So livestock products themselves have been trading on free range. So the more free range, the more welfare an animal has, the more it costs, the more their products cost, the meat or the eggs. And they're also very inefficient in terms of you need to spend a lot more energy heating a shed full of chickens that are free range than intensively farmed ones. So basically what I'm saying is, there's a new category that could be emerging, which is climate focused animal products that are fed using insects and doing other alternative proteins, or other responsible sourcing measures to make a premium climate friendly animal product. So this is not focused on welfare, while of course you could focus on both, but it's giving consumers an option to do a climate friendly product, not just a welfare product. They now have access to either side or a combination, and the price kind of scales with how you want to enter the market. So you're seeing a lot of companies, like a lot of supermarkets that I know firsthand are about to enter the insect farming space, are planning to build their own insect factories to use their own waste and to create these livestock products. Some of them are already out there. There's examples in France of fish that are insect fed. There's examples of chicken eggs that are in Morrison's. So lots of really, really interesting ways that we're going to be able to productize this. And that's not even to mention the frass side of things. It is such a potent fertilizer. It has all these really interesting properties. People are looking at coating seeds in frass. They are looking at doing all sorts of things, making briquettes out of them, using them in anaerobic digestion, because it's got a lot of microbial activity to really push or fire start some AD systems. And so we are just at the beginning of that. And a lot of the white space, a lot of the people who are going to do well in the insect farming space are people that are going to really focus on the productization part. Because realistically, a lot of the other parts in terms of how to domesticate flies, how to grow them, and all of that, that's kind of been figured out now. What we need is the new realm of people that are going to market, and they're going to think through and innovate products derived from insects or fed by insects, get them out onto the market and mass accepted. And those are the guys who've got the arbitrage now. The tech, the genetics, they're sort of being sorted now. We need to mature into pushing the industry forward. Similar with all of that, I'd say that roughly speaking, the industry kind of breaks even at the prices that are currently around now. It's still too expensive. So soy meal goes for $600 a ton. Insect protein goes for, like I said, between $1,000 and $1,500 a ton. And, fish meal might go for $2,000, $2,500 a ton. So insects are already kind of in the ballpark, but they're still too expensive, certainly when you want to replace fish meal. They are a animal protein, so it's more like they have more benefits. So your animals will grow faster. There will be all sorts of important benefits for using insects as opposed to soy, just like there is using fish instead of soy for certain species. And so, really, insects can stand on their own merit as their own type of product with their own interesting mineral profile, amino acid profile. But roughly, I'd say right now, it's fair to say that the best that businesses that I've seen out there are breaking even or operationally doing well. And there's definitely signs that the industry is hitting an inflection point where everything is going to start scaling up a lot faster. Now, I really want to zoom in on what's on my screen now, which is the genetic improvements that are currently under play. There are companies specifically focused on genetically improving the black soldier fly to make it grow faster, to grow larger. And let's just compare that with what happened with chickens, right? So since you can't see because my face is in the way, but back in the 50s, that was your average chicken. and look at your average chicken now. So with this isn't genetic enhancement or GMO. This is just through selective breeding. We were able to double or triple the feed conversion rate of the chicken. It carries a lot more meat on it now, the same bird, and it's a lot more efficient at converting its feed pellets into its biomass. And so, if we look at that same rate of improvement, but given that insects have such a short life cycle and have so many offspring, you could theoretically say that by the end of this decade, you could have the same improvement that it took 50, 60 years for a chicken to do. So when you start talking about doubling the performance of larvae as they stand, and that at today's pricing BSF is break even, well, if you do the math, it starts becoming a viable contender with soy meal before somewhere in the middle or just after the middle of the decade. So that's why a lot of people are maneuvering to get in. It's to figure out a business model, figure out customers where you get by and you improve on the productization and the genetics. So that's what I'm really excited about. So as I was saying, just to wrap this all off, if you are thinking about getting into insect farming, we've moved on from the old era where we just had big companies that did everything and they just had vertically integrated massive factories like the ones I've shown you in this presentation. Today, there are a number of specialized companies that are here to support existing food businesses to get in, to build the infrastructure quickly that works, that's reliable, that's turnkey. People do not need to be PhDs in entomology anymore to figure out how to get in. And like I say, where the attention needs to be focused now is not on the farm tech or the genetics. There's companies that are now raising lots of money focusing in those areas. The best is to not have to reinvent the wheel, leverage what everyone else has done, and focus on building a market that works with your natural arbitrages as a company, and make a power move in one of the most exciting alternative proteins. And that's how I'd say you can get the finances to stack up in the short and medium term, with the lowest possible risk. Because, of course, some of these companies can be operationally break even or okay, but in terms of return on capital, if you have to build loads and loads and loads of infrastructure without having sorted your market out, you're taking on a big infrastructural risk for an uncertain payout. Whereas if you start small and you build up and you develop your market and you focus on innovating the products, that's where you can then get the incentives to double down and keep going. So I hope that was interesting to everyone. As I say, you can contact me through my website, and please subscribe. Please give this video a like if you found it useful. It's going to motivate me to make others and to share this info with you guys. Please comment. Please comment if you like down below, and I will see you.